Three, two, one, and we're live. All right, welcome everybody. This is Omaha Data Science Academy. This is SQL 101, Class 6, Structuring and Modeling Data. I'm Jeremy Bergman, the professor for this class. And we have covered 5 classes. All of these involved going from the very basics of SQL to DML and DDL. So creating most structures to hold data and being able to manipulate them by inserting, updating, deleting. And in the last class, we did a lot more applied SQL as far as cleaning data and formatting and doing things with dates and strings and numbers, manipulating numbers. For the next 2 classes, we will be working more on how you'll see data in the enterprise. So a little less focus on SQL and more on relational databases, specifically databases that handle transactional systems and data from transactional systems, and then how you structure data for analytical systems. So starting to get a view of how data translates from systems into analytical processes in the organization, how these systems are designed, and how you could look at these and interpret these and being able to use them. So starting to take all that SQL knowledge and then how you can apply it within, how you'll be able to see it and apply it within an organization. All right. Next slide. There we go. So how today's class is structured, the first hour will cover online transactional processing. This is data that comes from systems like CRM systems, so customer relation management, ERP is enterprise resource planning, all those acronyms that you hear in business, even accounting systems, any type of system, they almost all have some type of database underlying them. And those are transactional processing databases that process transactions. We'll look at a couple of different ways that you design these. We'll look at ER and relational diagrams. How these are really like how you use diagrams to architect the database. So if you think of, structural plans for a house, that's really kind of the same idea. And we'll talk about normal forms, so how we structure data appropriately within tables to be able to create those relationships. So hour number 2, we will do data flow modeling. This is understanding how data flows, even from users and systems. And then we'll talk about online analytical processing data models. So this is how we would take that transactional data, translate it into what we can use for analytics, and then how we can structure that data. And then near the end of hour 2, we'll start to practice some of this diagramming that we learned in hour 1. And with the third hour, we'll try to open this up as much as we can, like we have other classes, for homework and answering any questions that homework to review. And then just answering any SQL questions that you have. And of course, I locked the dogs out, but they broke in here anyway. Oh, we'll just go with it. If I have to take a timeout, I'll let everyone know and give you a break. All right, so review of class 2 and 5. I opened up with this to talk about it. So this is all a data manipulation, from creating data sets, performing joins, aggregations, and queries, adding and removing and modifying data, and extracting and storing data. So you've done creation, extraction, transformation, manipulating data, and storage and retrieval. And these are really all the basic skills you need to be a data analyst. And now we're just taking these skills to the next level as far as how you use this data in an enterprise, what you might see, and potentially how you would even structure data yourselves for a system or for analytical purposes. All right, so class 6 objectives. We're going to talk about the purpose of data modeling. This is really architecting a system and having a blueprint for it. We have a couple different ways we can do this with entity relationship diagrams and relational database modeling. So out of this class, it won't be quite as important that you know how to do this as much as that you're able to read it and you're able to pick out things to understand how data, the relationships, how data is fed into the database, and then how it's created and constructed. You have a couple of different normal forms. This is just how you normalize data within a database. So when we talk about normalization, first normal form is really having a primary key. And then there are other ways you can decompose the table into multiple other tables. So you avoid like data redundancy and you gain efficiency within your database. So it's a key behind normalization. Analytical processing, we're going to cover dimensional data modeling. You'll often see this in a data warehouse in an organization. We'll talk more about data warehousing next week, but this will give you an introduction to how you can take some of this transactional data, you can structure it for analytical purposes in a specific type of data model called dimensional data model. And then we'll do an example database modeling on Sequila database. So there's a database out there, the transactional database MySQL gives us. It's fairly complex, but it will start to show you and understand like why it's important to be able to understand the relationships in the database, and then create an architecture that actually captures what you need in this. So this is like a video store example. So it'll capture customers, rentals, movies, actors, a little bit of everything. You'll start to see. It's a good example for looking to see how a database is designed for like an old school video rental store, which barely even exists anymore, but it's a good database. It's good to understanding it. All right. So the purpose of data modeling, we try to start out each lecture with one of these slides to really understand why we're covering this topic for the night. So database modeling is said as like creating a blueprint for a complex structure. It guides the construction of robust databases and efficient information systems. So you can think of database modeling. Data model is one and the same, where you're trying to capture transactions and to the most effective way possible. So you're modeling the data, and your data model supports your systems. So you have compatible data, minimum redundancy. You can integrate it with systems. And then your systems, of course, support your business. So whether that's like CRM or ERP, it can reduce risk, cost, increased effectiveness. Automation is a big one. The systems will automate some of your business processes. And data can help with that too, especially now with machine learning and AI. You create these data models to capture the data, and then you have systems or AI to be able to help automate things in your business or be responsive to change and so forth. So the benefits of database modeling, it illustrates the relationships and structures that need to be built to effectively capture transactions within a database. It meets business needs and rules. So making sure that you design the right solution up front instead of just building it and hoping you catch everything, is that if you do this work up front, if you design it well and you get the requirements, that you meet the business needs and rules that business users require. It also helps with the levels of abstraction. Not you usually go from the highest level down to the lowest level, so you can draw a high level conceptual model that provides a big picture view of the system. Then you could create logical models that represent data structures more specifically, and then your physical model would be like defining your tables and relationships in a database. We'll see examples of all three, but it helps when you don't know all the details to be able to design it at the high level, and then be able to design and architect successive levels of complexity. Database modeling gives consistency and predictability. Without any structure to your systems, it can become chaotic, and I've seen that with some operational systems, is that there isn't really a lot of thought to design, so there's tables and redundant data sources and inefficiencies all over the place. That's why you do database modeling, is to be able to reduce redundancy of data and so forth. And then it supports business processes, so it supports sales or marketing efforts or accounting efforts and so forth. So it really is like that blueprint, like you generally start with upfront to be able to architect the system that you need to be able to capture data, meet business needs, support business processes. Right. So first I want to just lay out definition, the difference between transactional and analytical processing. So going forward, I'll abbreviate this as OLTP. So this is called online transaction processing versus online analytical processing. So the two systems, or the way you design them, have very different purposes and focuses within a relational database. So the focus of this first part, and what I was talking about in the last slide, primary focus is OLTP. This would be ordering processes like order processing, inventory management, customer support, or CRM, customer relationship management. This is ideal if you're just trying to you design it for capturing transactions fast. Think of a situation where you literally have millions of transactions. Really, you're just trying to design it efficiently to be able to do that. Very first job I worked at is First National Bank of Omaha. So worked in credit card center. They had over 1 million. There's like 1.5 million active users who were transacting on their cards every day, and then their customer information and account history and transactions are all updating in real time. And you're just trying to generate that system that, one, captures that information, and two, captures it with the speed and efficiency that it needs. But online analytical processing is different. So that often takes data from transaction processing systems, and it helps with complex analysis and queries, data mining, forecasting, using pre-existing business rules. So these business rules may be different than transaction processing. These may be business rules that are used for analytical purposes also. So you take this data, you transform it, you store it for use in analysis, and then you start defining calculations or business rules and things like that. Maybe it's advanced metrics that you're going to do that the system doesn't provide. Maybe it's a rolling history, being able to capture that the transactional system doesn't hold record of. So it's really designed to be offline outside of these transactional processing systems, and then used specifically by data analysts and data mining, or used specifically by data analysts. Now, not every organization is going to have OLAP. I've worked at a lot of places where they just pull data out of their transactional systems. It works for a while until you start to try to capture history, or you try to capture business rules, or you try to go back historically, and that data's gone or it's corrupted or something like that. So eventually the need, plus it's inefficient too. You may spend a lot of time in the systems trying to get data from it. Get data, just pulling data and cleaning data up. So eventually companies, hopefully they make the investment in the online analytical processing area to be able to do this for faster analysis and forecasting and application of business rules. So the reason why you use analytical processing is that database servers can only process with a finite amount of computing resources. Their job is just to capture transactions. The last thing you want to do is be able to pull out of those systems by analytical functions and like compromise the transactions that are being processed by those systems. It allows day-to-day operations to be unaffected by analysts and stakeholders. So I've had this happen to me a lot as an analyst, is that I needed data, but it only lived in an operational system. I pull the data, then the IT, the developers, or the database administrators get angry with me because I'm bottlenecking their transactional system. So that's why OLAP exists, and OLTP is a different creature, and rightfully so. And hopefully, they said you get to the point where the organization invests in OLAP. But summary, decoupling those improves performance, scalability, and consistency of data, and also gives you a sandbox to work in as an analyst. If you have OLAP, then you can add yourself to a database, create tables and stuff without compromising the transactional system that people depend on to do their work. So that's all my experience with those two systems. Finally, the last thing you want to do is the last thing you want to do is disturb business operations to where people can't do things because you're pulling data, and why the two systems exist. All right. So database modeling techniques. So I wanted to cover the difference between that, so this will make a little more sense. So 3 of these are specifically for online transaction processing, and 1 is a design for online analytical processing. So an entity relationship diagram model, it's a logical model that describes data entities and basic relationships. So it's 1 step above a conceptual model. You're starting to get down to a relational database level and defining relationships and what those entities and tables may look like. Relational modeling is where you start to do the physical model where each table is an entity with properties and relationships, usually defined by programming concepts and the system itself for transactional system purposes. So physical model is where you'll start to get down to what are the primary keys, what are the constraints, what are the data types, what are the field names, and so forth. And data flow modeling, it's a little bit different, but it's important to understand this. This is more of a conceptual model. This visualizes how data progresses through multiple systems and processes, including input and output. So this would be an example of a data flow diagram. You have a customer who confirms order details. Then they order parts from the supplier. And you'd really be surprised as a data analyst. It's really important to understand how data flows through a system, and understand how that's being generated, or possibly there are errors in the process where it's being misgenerated. Melinda brought one up before class, actually. Maybe there's a process error in how people are entering data into a system. So maybe it's a sales rep is entering addresses into a system, but they're doing it incorrectly for whatever reason. They're defining street, or it could be any number of things. That is only known if you really understand the process behind how that data is being generated. So data flow modeling will help you conceptualize this, and then you go to an ER diagram or relational diagram, a physical diagram, to be able to help you get to the tables and the data you need and understand how the data works through it, so you can change that process or fix that process or fix the data itself. Then dimensional modeling is physical model where the data is organized into facts. Your facts are like your measures in Tableau. This would be like sales and revenue. And then you have dimensions, which are things like time and location and product. So I believe it's called dimensions in Tableau also. But so it's your measures and your dimensions there. And these are for analytical purposes. This is a way of capturing the OLTP data and then converting it to OL analytical data, where it's easily organized for people to do analysis, or importing it into a tool like Tableau for analytical purposes. All right. Go ahead and keep moving. So wanted to do a lot of definition up front before we really get into the rest of the lecture today, so we don't get lost in any of it. OLTP modeling, covered this pretty thoroughly by now, but it is focused on the operation of a particular system. Its goal is to design a database management system, relational database management system that captures events. So this would be kind of like a conceptual model, but it shows how you would see business, that you'd model business activities and you gather requirements to be able to create your logical model, which comes into being your conceptual data model. Then the technical people, like a database administrator, would help create a physical model that's, performance considerations and how that translates into technical environment. Becomes a physical data model, and then starts to populate with business data, and it continues to update and create data for the system, and then potentially data for the for analytical purposes also. But this model overall shows how information is stored and relates to other data. Just walking through that. These are formal mapping processes, the conceptual data model and physical data model, and it helps map the database schema. And we'll see this in a couple slides coming up. Right. So first is entity relationship diagram. So this is a logical model going from conceptual, the highest level, as we start to see a little more detail. We're really defining entities, attributes, and relationships between the tables. So an ERD diagram describes how entities are interrelated in a specific domain of knowledge, along with the relationships that come between them. So these are going to start to form really natural language. They're going to relate directly to not natural language, but relational database language. So your entities or nouns describe the business events of an organization. These are going to be the tables that you design. Your attributes support decision-making, reporting, query, and analysis. Your attributes are going to be your column names. So if you think of like a car, you'd have like car color, transmission type, miles per gallon, whatever you could attribute to a car, the adjective to a car, those are going to start forming your columns, even price. And then relationship is the key business entities upon which transactions are excluded and the dimensions around it which analysis are conducted. So it describes the key business entities. So to put that in kind of layman's terms is these are somewhat like the verbs and like how these are related. Like say it's like a car salesman selling somebody a car. So it'd be like car salesman sells customer to a car. The relationship would be sells. And then there would be a key between them, like the salesperson, the sale would have a salesperson would have like a key to a transaction that a customer made. We'll see some more of these coming up in here in the next slide. That's better, a little bit better described. But going on a little bit more, the degree of relationships. So there are a couple of different types of relationships that tables, or here they call them entities, but essentially tables can participate in. A urinary relationship is when it refers to itself. This would be like an employee and an employee manager. You could have like a link here all the way up the food chain from employee to manager, and that's an employee who has a manager, and then so forth. Binary relationship is one that you have most of the time. These are just direct relationships between two entities. A ternary relationship describes three or more different entities to each other. Usually this is some table that maps this entity to this entity. We'll have a good description of one coming up here. I won't try to do that, but sometimes there will be things like a customer transaction, and you need some table in between to map the two together to be able to create that relationship. So it's like a relationship in the middle. Right. So this is also important to understand is the cardinality constraints. So the number of instances of one entity that can or must be associated with the instance of another entity. So you can think of this as they're both optional and mandatory one-to-one relationships or optional many-to-many relationships. So an example of an optional one relationship is, so if there's an order, it may be transacted by 0 or 1 employee. So it's optional. So an employee doesn't necessarily have to make a transaction, but at most there can only be one transaction that's assigned to an employee. Or one for a transaction, only one employee can be assigned to it. So optional many. So each product may be a part of 0 or more orders. So if you're doing product and then mapping it to orders, so a product could possibly be on 0 orders, but it could also be on many different orders. And the same is mandatory, except instead of having an optional 0, they all have to have at least one or many. This is important when you're joining tables together because to understand if they're a one-to-one relationship, if one table maps directly to the other, or if it's a one-to-many relationship. So like customers and transactions, mapping those together, you're going to get a larger table because there are multiple transactions that can map to a customer on like a customer ID. So you may see that as you work on as you work on joining data within databases. You may have already seen that in like the world databases, whether like something like multiple states would map to a or multiple cities would map to a state, but a state can only map to one city. So, well, there can only be one city per state. So, yeah, you can see the language takes some getting used to, but one-to-one and one-to-many relationships they're really important to understand, especially when you're bringing data together and then designing database tables to do that. Are there any questions so far? All right, we'll keep moving. I think this might bring it down to earth a little bit. So this was a project that I worked on, helping design a database for tracking customer repairs. And my monitor just went out. Hold on one second. Or my monitor just went off. Give me 1 second and I'll be back with this. Okay. See if I can get that back. Okay, I think I'm back here. Looks like everybody can see. All right, so this was a project that I worked on as a repair tracker. So tracking repairs and tracking repairs on vehicles, like the invoices and service records, and then vendors, like who actually did the repairs. A repair subject would be like, did they fix a car? Did they fix a truck? Did they fix a van? It's typically cars, but the idea is that you could extend it to boats and everything. And then what type of service and who was the owner. So we went through this exercise to be able to create an ERD for them. We gathered these requirements and asked them a bunch of questions. So this is also where we're going to start to form like the one-to-one or the one-to-many relationship. So it becomes natural language. So you could have multiple vendors can have relationships with multiple owners or no owners at all. So that would be like a many-to-many relationship. Then multiple owners can have relationships with multiple vendors or none at all. So you always go in the reverse direction also. So owners can have relationships with multiple vendors or none at all. So you're defining these relationships in both directions. So here's a different one. An owner can have multiple service records or no service records at all. That makes sense because an owner could have multiple vehicles where they have multiple service. But a service can be approved by only one owner. So a single service record can only have one owner on it. So that defines a two-way relationship, and this would be like a mandatory one. Read a couple more. So a service record may contain many invoices or none at all. So within a service, you could actually have multiple invoices. If you brought your car in for multiple things, multiple issues, maybe you'll have multiple invoices. And then multiple invoice must belong to only one service record. So even if it's those multiple invoices, they belong to a single service record for a single service. So let's take a look at, with all of these rules, let's take a look at what this database ends up looking like. So let's take one of these. An owner can approve multiple services, and a service can be approved by only one owner. So we have owner and service. So this is where we're talking about the relationship is defined by a verb. So we say an owner approves a service. So an owner can have multiple services, or optional. So this would be optional. Say an owner may not have any service or have many services, and an owner, let's see, so the service can only be approved by a mandatory one owner. So we have all three defined in this case. We have the entity relationship diagram, where we did this at a high level. The entities, where they're these tables. We're starting to do some of the start of a physical model by doing the attributes or the adjectives within the table. So within service, you have a service start date and service end date. Within an owner, you have the adjectives that describe the owner: name, address, phone number, and phone type. And then you have the relationships, which are the verbs, which is like approves. A vendor provides a service. A vendor selects a business campaign. An account or a vendor registers an account, and so forth. And here's one of them from earlier, where there's a ternary relationship. Is that you have a vendor, and then you have an intermediary table with a relationship that connects to an owner. So when we talked about ternary relationships, that would be one, the relationship. And you could know that because it has a foreign key. The relationship ID is a key, but it connects to vendor and owner. And that's like a cross mapping between a vendor and an owner. So if that seems like a lot, I just wanted, not expecting you to be able to design these necessarily, but just to be able to, if you see one of these, help navigate your way around online transaction processing designed database for a system. So now you would be honest, you'd be lucky if you had this type of diagram and somebody spent the time to do it. In bigger organizations, they do. But oftentimes, you may have to end up figuring out these relationships yourself in the absence of these diagrams. And it may not be nearly this clean of design. All right. So relational database modeling, you'll probably see this one the most. And almost all systems do this to some degree, whether they've just added a bunch of tables and relationships all the time. But relational database models, they convert the conceptual representation of entities. So the more conceptual, to a model that can be implemented directly in a database, which is a physical model. Now that you've defined all these relationships, you can define the keys, you can define the attributes, even foreign keys if needed, and then all of the data types for each field. So you see how going from the highest level of requirements and systems mapping down to your enterprise, and then down successful levels leads you to a design that you can implement straight into a relational database for transaction processing. Sorry, excuse me. All right. So we'll cover this with the last 10 minutes. So normal forms. This is how what you call normalized data within your data tables. So As part of this design consideration, you also want to consider these normal forms. So the normal forms are standard rules for structuring a database to reduce redundancy and increase data integrity. It also increases performance too, as far as minimizing space costs and processing time and errors. And denormalization, this happens in analytical processes, but you take a normal form and you selectively increase redundancy to improve speed. So occasionally there's some trade-offs between these normal forms for analytical processes or for speed considerations in a database. That's what a database administrator is all about, is like, how do we optimize this database and this system for the processing within the database. But the rule is here is, well, it's kind of a saying. Every non-prime key attribute must provide a fact about the key, the whole key, or nothing but the key. So that doesn't, you probably read that and say, I don't know what the heck that means, but that's okay. We'll cover examples of first and second normal form here in a second. But the idea is the first normal form, every record within a table has a distinct key that uniquely identifies each record. That's what we talked about creating tables in previous lectures about, is defining a primary key. That is basically that, and only a couple of other rules that we have for data that would get you to first normal form. And second normal form is a decomposition of first normal form. So think of it as like breaking a bigger table into smaller independent parts. And sometimes that's possible. Sometimes maybe you have a whole bunch of data in here, but you say, hey, we can actually separate this into separate this into two different pieces. Think about the example that we have coming up is like company and stock symbol. So, well, it's a company and stock symbol and then price of the stock. Instead of having it all in one table, you could actually break this into one table that's company and symbol, and then another one that's symbol and price. So we can see like where we have opportunities to break those tables down into further tables. All right. So first normal form. So the requirement, like I said, the table has a primary key. So here each attribute value must be a single value only. Say each attribute column value must be a single column value only. All values for a given attribute must be of the same type, so all these must be text. Each attribute column name must be unique, so you have to give all of these columns different names within a table. The order of the attributes is insignificant, so if these were in different order, you'd still have your primary key in the same data. No two tuples in a relation can be identical, so if they have, you can have no duplicate records across the key, and the order of the tuples of the rows is insignificant. So it doesn't matter that these dates are all aligned, it will end up giving you the same data. So a couple of these are just natural to databases itself. Like even if these records aren't in like an expected or sorted order, that it still works out. So each column value must be a single value only. So you see this actually has a composite key that doesn't use just one field. It uses a composite between symbol and date to be able to uniquely define each row. So here it'd be Microsoft on 9/7 would uniquely define this row. Then on 9/8 it would uniquely define this row. The key uniquely defines rows within the table. And then these are all the same type. The column names are all unique. The order of these is okay. If they're changed up, it's okay. None of these can be identical, so there can't be two of the same record that having the same key. And then the order of the tuples, the rows, is insignificant. So this is what we call a well-formed table within a database. So first normal form is just a baseline for designing and storing tables, is that you have a primary key with it. So now you can actually create tables in the database that have no primary key, but then it would be not a well-formed key. So if you're designing database tables with relationships, you really want to have a primary key with it. All right. So second normal form, the base requirement is that the table is already in first normal form. This is what we saw. So the relationship is in second normal form if all of its non-key attributes are dependent on all of the key. So some more database type lingo, but what that means is that these non-key attributes are dependent on the symbol. And you see, so the closing price here is dependent on Microsoft and the date, and the headquarters and company is dependent on the symbol. So you can actually start to see, if you're able to decompose it that way, you can actually take this data and break it down into two separate tables. Now you'd say, well, it just provides me the information anyway. It provides me all the same information anyway. Well, there you combine it like that. You can see it actually has it's a little bit smaller in size without having as much redundant data, which makes it like easier to update or add additional transactions to it. So that's why you would move that to second normal form. Relationships that have a single attribute for a key are automatically second normal form. So this way, since it's not a composite key, it's automatically in second normal form. And this is one reason we often use artificial identifiers as a key. So artificial identifiers would be like a numeric ID. You'd do like customer 1, 2, 3, 4, 5, 6, 7. This is really common within databases to use just like a company ID instead of a company because it lends itself really well to being fully normalized within a table. So you'd have company ID 1, 2, up this and so forth. And then you could use that as a key in another table. So that is a lot of online transactional processing and design. And we're coming up right to the hour and we're on track. Does anybody have questions about what we learned so far, or is everyone's head spinning a little bit? Let me know how you're feeling.
So if I'm recapping right, so like a 1NF is kind of a standard table where everything is kind of listed. The 2NF has some of that information in one table and some of that information in a second table, and they are linked by the symbol. Like in this example, by the symbol, they're linked by a primary key. Am I recapping that correctly?
Yep. And this is broken down into two tables because these are just fully dependent on the symbol, on a
Right.
single symbol.
And it could be more than 2 tables then?
Yep.
Okay.
It can be decomposed into multiple tables. There's also, I left a note at the end, an appendix. There's a third normal form, and database administrators or designers love third normal form, but it's really hard to explain. It's like taking this and going like another level further. And then there's like a whole bunch of database theory, but for this class, we don't really need to get into that. Just knowing that there's a way to properly structure a table and then even break it down farther for database design is good enough, and then and why the importance of it and why you do it, and within a recognizing it within a system. Like I said, I've dug into systems before, and to be honest with you, this kind of stuff wasn't done. And then the other people who run the system, they're hesitant to do it because you dig into it and you see like all this stuff and what they've done under the covers. But this is all of this is best practice. So your system doesn't become eventually like bogged down, or your data stale or inefficient or has errors, or your whole system becomes inefficient. Really, over time, if in IT, if you're adding more and more to systems over time, it just bogs it down and bogs it down more until some redesign or some other consideration has to happen. No matter how much people want to keep adding and adding things to it. That's why you have database administrators and system administrators and architects and stuff like that at big organizations. All right. Everyone's good for a break. I think that's quite a bit. So we'll go ahead and let's do a 10-minute break since we're all online, and just go around the corner for a drink and restroom break. So can be back here pretty fast. Grab a quick snack and see you here at 7:13, about 7:15. We'll start at 7:15. Sound good? All right, sounds good to me. Be back shortly. I'm back. And after you're talking before class, I imagine you have like a multi-course dinner in front of you while you're learning about database design.
Yeah, I had a pretty stellar dinner. I'll be honest. My husband made like honey sriracha chicken with like rice. It was really good.
That's a huge win, having somebody cook for you when you're doing night classes or night work.
Yeah, we kind of created the system where we take turns having a week where we plan our dinners. And so like we're like the person whose week it is in charge of planning the meals for the week, like doing the grocery list, grocery shopping and all of that stuff, and just kind of figuring it all out. And then we take turns. And it's kind of nice because then like one person doesn't have to like think about it and worry about it like the whole week. It's just like done. So this week is his week to do dinners, which is nice.
Yeah. Awesome. It's good teamwork. Like to try to think of making things efficient and as automated as possible.
Yeah.
And I'm going to start ordering some of my groceries.
Yeah, it's been
come up with a plan list and have it delivered.
Yeah. I haven't done delivery because I'm very worried that like they're gonna either send me like bad produce or something, or be like, we don't have that one thing you want, and I have to go make another trip anyway. And so I'm like, I don't want to do it.
Yeah.
It's just like not worth for me. Like my anxiety, my brain doesn't do well with that. But I can see why so many people like it. Maybe one day I'll get better and do it, but I get to the store too, and I start to be like, well, maybe I'll do this, or maybe I'll do this. Like, I don't know. I overthink things a lot.
I'm old-fashioned too, so I'm a creature of habit, and I still go, but trying to think about a way to have it taken care of.
Yeah, I've definitely found like the avenues in my life where I can like do shortcuts that like work for me. Grocery shopping quite isn't there yet for me, but yeah, I'm definitely trying to streamline my life a little bit here and there.
Yeah. I just was gonna say I didn't quite have the 3-piece meal. I had a cream cheese bagel, but nice to have the convenience doing this from home. But we'll do this. We'll go back next week to Elevator to finish the last 2 classes.
Oh gosh, yeah, next week is the last week. Oh my gosh.
Almost to graduation already.
I know, this is speeding, and I'm like I don't know. It just seems kind of crazy that it's almost done, and then there'll just be one more class and then it's done. And I'm like, okay.
It's like an abbreviated college semester, so
yeah.
I was doing night classes at Creighton for MBA. It was like a 3-hour class once a week for 14 weeks. So you had 14 classes instead of 8.
Yeah.
3-hour classes. But we pack into it what you need to know in this one. But yeah, and I was going to tell everyone as a data analyst, you don't do a lot of like the design of transaction processing systems. That's usually like development teams and that architect. But it's possible with the stuff that we come up with next. But tell you like one of my recent experiences I worked for an oral surgery company that was doing mergers and acquisitions. So they had no common like analytical data model. So everything I was doing was pulling it out of transactional systems and then moving it over to the analytical model. I had to like know all this stuff, and if document existed, that was great. Otherwise, I had to reverse engineer like database systems to try to do that, and it's all sorts of database systems and different dental management systems on top of it. So like learning the processes that I had to get with like some of the practice managers and learn the processes of how they did things.
So is it? Yeah. So is it
scream when I did it? Go ahead.
Yeah. Well, I was gonna say, like, is like the idea here, and like what you're talking about with your work experience? Is it like, okay, I'm going to work for this place, and they have all these different spreadsheets or different like reporting that they can pull from different platforms, and my job now with this is, okay, what are like where is like maybe a commonality, like a primary key, or like how do I see how stuff is getting put in here so that I could say, okay, this is how the tables should look so that you can actually pull data from them meaningfully. Is that what we're kind of looking at here?
Yeah.
Okay.
Yeah, the idea of how these databases would be designed in systems.
Okay.
Using SQL in relational databases.
Okay.
And then being able to read this type of stuff or know where it's coming from.
Okay.
And how it's designed to be able to pull out data. And hopefully this documentation exists. If not, you're in the business of trying to figure it out yourself, like reverse engineering the database and figuring out the processes and workflows and stuff like that, and then how everything's connected. Usually within systems, tables are named in a descriptive manner, so you can kind of tell, but not always.
Okay.
So if you ever have to do it, you may have to reverse engineer one of these diagrams, which is kind of a cool feature. I should actually show everyone. In MySQL Workbench, there's actually a reverse engineer feature.
Oh, okay.
Let's go. Try to pull this up. I was going to wait till later in the class, but since I'm talking about it, this is our new database, this Sequila database. And this is like the video rental store, like a Blockbuster.
Okay. Can you switch to this? Are you showing it on another screen?
Oh, yeah, I thought. Okay. I thought I had that on the same one. Hold on. Yeah. Hold on 1 second. Entire screen. Let's do that entire second screen. Okay, now you can see it?
Yeah.
Okay. So Sequila database is like a Blockbuster, like a video rental store that no longer exists. But you have these tables. Mm-hmm. Even just looking at these tables, you have to kind of start to pick together the relationships, and you could do that from like primary keys that are underlined, right?
Okay.
Or these in black, they're the foreign keys to other table. So for like a payment, you have a customer and a staff and a rental attached to like a payment.
Okay.
But within this, it's kind of cool. If you go up here to database, you select your database, you can reverse engineer it. And I believe everybody can do this. If not, with the permissions they have. If not, let me know and I'll figure out the right permission. Okay, so I'm connecting to the database. I'm going to Sequila. All right, so I hit next, select objects. Oh, that's fine. It just wants to get the tables, the views, and other objects out of the database. It's all fine. Reverse engineer, and voila, you have like even deeper than an enterprise or a entity relationship diagram. You have all the relationships behind them, and then you have like the physical model, which tells you the column and what type of what data type they are. Like some of them are tiny ints, timestamps. You can see what the primary key is through the key. You can see foreign keys like manager, staff, and then last time update. The lines in between are like all the relationships and the cardinalities that we talked about.
Oh, okay.
So like you have from rental to address, you have a mandatory one, or you have a mandatory one-to-many on the rental. And then you can see this, and then you're like, well, I need to get a film, and how many rentals has it had? You may have to go through a couple tables to do that. You may have to trace the relationship. You may have to go to film. And how would we even get to that here? Sometimes you can spread these out a little bit. Film, store, film to store to address to rental. You can see as like the number of tables grow, like the harder the relationship becomes to figure out. I guess you would tie it to the rental ID, film ID. I can't even determine it at this second if I sat down and did it, but this may be how you have to trace through a database to get the data that you need, which can become very technical and take like system knowledge to be able to do it.
Okay.
Film rentals. But I have had these things where I just pasted like 50 sheets on a wall, and it's just like full of these tables. It counted like 700 tables, and then I just took a marker, and that's probably it. I just took a marker and then like trace the relationships and be able to get the data. And if you're designing a complicated system, right, like it may be like really hard to think of all these relationships that need to exist. So that's why you design the database ahead of time. That's why they design it for systems. Is so that the more complex your system gets, the more accurate you'll be in capturing what you need to capture. So building a new system, it's a difficult thing, really. Especially a complicated system. I'd almost always recommend if you're building a system within a company, it should be for a really good reason that you need a custom system. Otherwise, I'd probably just buy one because of the work and gathering requirements and everything that's needed. Or it's you're in some niche or really custom type of business that needs a specialized system. But almost all of it, but there's a software for almost everything now. But anyway, that's my tangent. But you can reverse engineer and be able to get the relational database models. It's like a combination of the ERD and relational database models to start the trace. This one's like becomes a lot easier. The relationships are a little more straightforward. So you could see, you could do a vendor to like a service ID to like the invoice and the repairs made on the vehicle pretty easily. So if you wanted to get the repairs made by all vendor, you would trace it through service and invoices, and then all repairs on the invoice. All right. Okay, we're going to go ahead and start with the second part. The second part's really about, of this lecture, is really about how data flows through a system and then designing that online transactional data for analytical processing. So data flow modeling is just like it says, is that it describes the flow of data through a system or a process. So it models the following interactions: processes performed on data, where the data is held. So things here like customer information be held in customer table, carrier sales orders, so forth. And then the people and systems that interact with the data. So not just like the processes and the data, it's like how people interact with it. This is like really important from just a description or the my experience that I talked about with practice management systems. All of them entered, even if they had the same system, they all used it a little bit differently and would enter things in a little bit different way. And it's really important to understand like their processes and how they coded information, like billing codes, and how what they were doing were different, and how they went about certain things. So you may be scared to know this, but not every practice is like, even in oral surgery or stuff, they code medical procedures in the same way, even if it's like the same procedure. So like knowing like how that person enters things into the system and why they do it, and then being able to tie like disparate systems together is like, it's like a must. And what I was doing, like the systems and data integration and creating the analytical models. It is also useful for identifying areas in inefficiency or design and to communicate system requirements. So you can start to see this in data if there are a lot of errors in the data or people are doing things wrong. You as a data analyst could put this in a dashboard or report and be able to see like the things that they aren't doing right in their process and then make those corrections. That's probably one of the bigger areas is of being a data analyst, is identifying some of those and making recommendations on how you'd improve processes, or like maybe it's controls you put together in processes, or just rethinking the process altogether. Data is very helpful in, one, understanding the process, and then two, like if you understand how data is generated in the process, and then next, like fixing processes that are broken or inconsistent or inefficient. And that's where data flow modeling is helpful, especially if this gets complex and it's like between multiple systems. It actually provides, I've had this before, and it provides a really valuable roadmap between interactions between people and sales and accounting and then various systems within an organization. It's probably it's a conceptual model at the highest level, highest picture of like everything in an enterprise put together usually. But can also be as deep as like a single system or almost a single process. All right. So important to know how data flows for analytical purposes. So this is where we start to talk about OLAP, is online analytical processing and dimensional data modeling. Like we said, the purpose of analytical processing is putting data from, whether it's transactional systems or other data sources, even surveys in a way are transactional. Each survey is a transaction. Or even if data from people enter in a spreadsheet or something, text file or whatever it might be, it takes all that information and puts it in a model that's easy to consume for analytics and makes sense for analytics. So like storing historical data or business rules for key performance indicators that may not be captured in systems, or other business rules or groupings. So two of the most common, the star scheme is like probably by far the most common. It's a very simple, straightforward design where you have your facts here, or like your measures. So you have your primary keys, and then you have price and quantity. So your sales price and your sales quantity. And then what the dimensions do, these are like your nouns or your store, your sales type, your products, your employees, or your time. Those are your dimensions. And it becomes very easy to get answers like, how many sales were there? What is the sales quantity for a given week? What was the total revenue if you do like a week by price by sales? Or for a given product, what was the quantity sold on a given week? So these tend to be first normal form tables, and then joined with this table with one, two, optionally many relationships. So the advantage is this is a really simple, straightforward analytical model. Works super well in Power BI. If you were just to paste the fact sales table and you connect these other things, then you could recreate this model and answer all sorts of questions. The disadvantage is you take normalized data and you denormalize it, in a sense, is that you're trying to do it for analytical purposes instead of optimizing it for transactions. So it can increase space and cost and data risk, integrity risk due to redundancy. So you have some redundant data in here that you may need to make sure that's updated correctly and that the data model's updated correctly. But usually you'll have, if you've invested in data warehouse to this point, you'll have some type of data architect or database administrator who's really a data architect, but making sure like the data warehouse tables update properly and everything goes smoothly. Or a data architect or data engineer would do that, and making sure this model stays up to date for analytical purposes. Right, so Snowflake schema is less common. You can see these are like much more normalized tables based on store. This is where you go down to second normal form. And this is a good example, Melinda, of a table that not just you create two tables in second normal form, you create multiple tables from it. So store, you're able to create a city table, a region table, a state table, and a country table, which is kind of remarkable in itself. But you keep that because you have low data integrity risk, but it increases the complexity. It makes it a little more difficult because you have to trace through relationships to put your query together. Like if you wanted to get sales by state, you'd have to do state joined with region, joined with city, joined with store, joined with back sales, instead of just doing store and sales over here. Sometimes a secondary relationship is necessary on these analytical models, like a reference table. Trying to think of a good example I had. So I worked in supply chain at a distributor. They distributed wireless accessories for phones, like cases and screen protectors and stuff like that. So you had a DIM product, but then on top of that, you had a DIM phone reference, which would be like what model of phones were those products compatible to. And it literally was like one of these products could be compatible with 10 different phones. So include it, instead of making this table enormous, you had a secondary table that you could reference if you needed to know what phone or what products are related to what digital device or what phone. So these have some design considerations. The BI developer could even do this if the BI developer is skilled enough to know dimensional data modeling. But you can see how it's more readily designed to answer the fast speed questions that business managers may want to ask, as opposed to having to trace through, well, these aren't even that bad, an entire ERD schema to be able to get to the data that you need. And even at that, it may not be, the business rules may not be applied, or there may not be something not quite right with the data or how you pulled it together to answer that question. So this online analytical processing actually becomes more reliable for answering the types of questions that businesses would like to answer. And out of the businesses I've worked at in my career, about half of them had this, like analytical data marts and analytical data model to pull data from. And the other half, usually they took it straight out of the transaction processing system. So one of my jobs is, as a consultant, is recommending how they use that data for analytical purposes. And oftentimes it's creating extracts out of systems and landing it and turning it into analytical data that can be used, or data models that can be used, and helping them get to that point if they're interested. And some of their tools that help you do this too. So I want to explain more a little bit about that. So taking all that data, transactional data or other data, putting it in this format so you can more readily answer those analytical questions, especially historical based questions. Okay. That's actually it for class 6. So we'll review. So transactional OLTP models versus analytical processing, two very different purposes, but both you see you can do in relational databases. And they are tied to each other in the sense that transactional data is often fed into analytical processing, but this one's designed to capture transactions from a system, has a very formal process. You have your ERDs, you're defining relationships within a bigger system to be able to catch whatever you need, versus analytical processing is like, then you're taking that data and transforming it into what you need to answer questions and then storing that data. So database modeling techniques, we learned these for OLTP. You have entity relationship diagrams and then relational database modeling. Normal forms, we did first and second. I have an appendix on third normal form in these notes. And then we last learned about dimensional data modeling in OLAP. So on Monday, we will go more into data in the enterprise, and you'll see where dimensional data modeling fits into the bigger picture of like data warehousing and analytical data marts, and this end-to-end, like how you take data out of systems, how you store it, how you transform it, and how it's used for analytics. You'll see a more end-to-end, bigger picture, but for now in this one, just understanding how this data is converted into analytical data in a dimensional data model that analysts can use and the organization can use for answering questions. Right. So additional resources. One of the things we're going to do for the homework is to create a diagram. My personal preference is to use it's called diagrams.net now. It used to be Draw.io, but it has all sorts of tech related diagrams that you can draw, whether it's cloud or ERD diagrams or relational diagrams. It's free. It's really easy to use. It's just drag and drop. I'll show an example of this before we get started on the homework. There's Microsoft Visio. It's the same thing. It's just a little more polished version. You have to pay for Microsoft Visio. It doesn't even come standard with Office 365, but if you are so inclined or you've used it before, you know that you can diagram lots of stuff. You can even diagram data workflows within it. Many other options. Yes, I've listed some of them over here. Open Office is like the open source free version of Microsoft Office. And Google Drawings, they always have their knockoff version of what other people are doing too. So that's also an option. Right. So that's it for the lecture. Third normal form. So just really, this is like a database administrators and architect's dream right here is third normal form. That basically just the takeaway is like table is in second normal form, and then you could break it down one more time, even to third normal form. So that way, if you're updating the company symbol, then yeah, it's just easier to update things. All right. So we actually also have a exercise to walk through. I don't have answers written out for this. So in your next homework, it's going to be mostly answering these type of questions about like entity relationship diagrams. Yours is going to be on the consoles data, but we'll quickly go over the Sequila schema. And this is actually laid out a lot nicer than we saw when we reversed engineering the database. I think that I could more easily find the relationships in here instead of all those lines drawn all over the place. So like if you wanted to do something like film sales, let's see, I think that's what we were doing before. Store ID, customer rental. You could go film to inventory to rentals and count the number of rental IDs or something like that. So this was a lot better diagram than the one that we reversed engineered in MySQL. And hopefully you would get something like this if you were asked to do the same. I'll let you ask the group here a little bit. So utilizing this schema, does anybody identify entities and attributes in the schema? Say, remember the entities are like tables and the attributes are like the fields. It's okay if everyone's shy too. So entities would be like your film table, your inventory. These are the nouns, staff, payments, rentals. Usually in databases, database management systems, if it's being used for an application, they're usually pretty well described, or they have straightforward names. Sometimes the data in them could be something different than you expect. So if you're like reverse engineering a database, you may have to dive a little bit deeper to see what's actually being recorded for the customer. But most of the time between the name and the column name of the table and then the column names, you can get a pretty good idea of like what's being captured and what type of data in it. Then the attributes are just each one of these things that are being captured for the film, like the adjectives. So the title, description, release year, length, replacement cost, so forth. So is the film table in first normal form? If so, why? So it is in first normal form. And then if you were to go up back to the rules of first normal form, so all of these are all of the attributes in the table are uniquely identified by a primary key, the film ID. And then it doesn't matter what order the columns or the rows will be in there, you'll still end up with the same information. And then what was the other one? Form, value. They all the columns have unique names. And no two rows are identical. So for a couple of those, you'd probably have to go look at the data itself to make sure none of the rows are identical. But if you were to do this, you assigned a primary key to your table. If you tried to insert a row with the same key or the same information, you would get an error on it. That's why a primary key is a constraint, is that it won't allow you to enter that type of information into the data, into a table. It'll actually give you a warning that duplicate record exists. And it says, can you name a relationship that is in second normal form? And I had one. Here's one right here. So you have actor in the film, and you have a film actor here in between. Because in theory, you could connect all these together, and you could have a film and an actor table in one with all this information. But you've decomposed it down into film and actor from film actor using this cross-reference table. So that way it breaks it down. It makes it more efficient to update without any errors. And it ensures better data integrity also when doing updates. So if you had all these set in the same record, it really becomes kind of messy if you need to update a film information for some reason for all the film actor combinations. Instead, you just have all the films you can update, you have all the actors you can update, and then you have a film actor, and then the time it last updated also. All right. So then last, find the following relationships in the schema. There's a mandatory one to optional many, and optional one to optional many. So let's try to find like a mandatory one. Here's like a mandatory one to optional many. So this makes sense. So you can have a store and have multiple staff members. But then they're saying if you have a staff member, you can have one and only one store. Now, it probably doesn't account for like staff if they worked at a bunch of different locations, but that's how this database is designed, with the assumption that each staff would only work at one store. And you can tell that by the relationship right here. Right. So optional one to optional many. Oh, that was actually Store has optionally one-to-many staff, not mandatory one. So mandatory one. Yep, this is a mandatory one. Store to optionally many. There could be a store with 0 employees, I guess. And then mandatory one. Staff to optionally many stores. Yeah. All right. So optional one to optional many. Okay. Optional mandatory one. That's a mandatory one to optional many. Optional one to optional many. So this says optionally. Let's see. Optional. Let's do this one. Optionally, let's see. One address to optionally many stores. Let's see, I had one picked out here. Optional one, optional many. Optional one to optional one to optional many. Here we go. Optionally one rental to optionally many payments. So what this says is like, it's optional that there's a rental, and then if there is a rental, or then it's optionally many payments for a single rental. So if somebody had a rental, maybe they did more than one payment on it for whatever reason. You have a rental ID. Maybe they had multiple payments for it. So a customer doesn't necessarily have to rent anything, but then they have optionally 0 to, they can make many payments on a single rental. So that's the idea. It's sometimes it's complicated to trace through some of these relationships, but writing them out and, well, just really even seeing how they join and then looking at the data will really help you understand the relationships between these. That's the idea of the exercise. Then we'll take a break after I describe homework 6. This is going to be a little bit simpler. I sent out the template, updated template that includes homework 6. So it identifies the entities. So what you'll do is you'll take the console schema and then identify the entities, attributes, and relationships in the console data, and then create a small ERD diagram of the console schema in diagrams.net. So I'm not expecting you too much to even do the one-to-many relationships. Just draw the relationships between the keys of the table. And then taking this entity diagram, turning it into a relational model that you can create tables with. It's just really taking the ERD diagram and then listing out the fields and the data types and stuff like that. Taking that, then converting it to an OLAP model that uses business entities, dimensions, and measures. And then once you've designed that, create the SQL code that creates the OLAP relationship between tables. So in the homework, in the new template, I give you the answer to this part, which will help you design the OLAP dimensional model. And then you can also, I gave everybody access to the console schema, and you can also see the views that were created here. So all I'm asking for this part of the homework, class 6, is just to create these diagrams for it and understand the diagrams, and then create a diagram for the OLAP model based off of these views that are already created here in the console schema. So I should bring this up. If you go to the console schema, and you go to views, that's not right yet. I still have them in. I need to build them in the class. I need to build them in the consoles table or consoles database, but once I do, you'll have console, you'll have game pre-order, game sales, publisher, and I believe USA pre-order brings all of these together. But you'll have these five views that are part of an analytical data model that will end up, you'll be able to create your analytical data model from that. So are there questions or concerns about homework 6 or what I'm asking for, or in homework 3 and class 6? Hope if you have questions, just please let me know. I hate for anybody to get stuck on it or things to be confusing or like that. So it's really supposed to be just an exercise to try to build these diagrams for yourself and like a relational database model once, and then see how that would work. See how that worked within database. And then using those resources that I had on the slide, the Dry.io is one of the best. I actually have it bookmarked. If I bring up, hold on one second. If I bring up my web browser, actually one of the sites I have marked as Dry.io. Oops, I don't want to leave the stream to do that though. So let me do something real quick. Okay, that's probably a little bit better. You could save it in OneDrive, or you could save it in Google Drive or wherever you'd like. You don't necessarily have to do that. Or maybe I do. I don't remember having to. Oh, that's because I went to an existing one that I created. If you go to just app.diagrams.net, you can save it to Google Drive or Dropbox or your device, or decide later. And then in here, you have specifically entity relationship diagrams, which is why it's one of the best to use. You have things like flowcharts even to document processes, like we did the process mapping. All sorts of different flowcharts and diagrams in here, even for programming and like doing user roles and stuff like that. But you have entity relationship diagram and pull these in here. You can do your unique ID. You can define your columns and then relationships between each. That's another entity. Do a table. But that gets the idea, and then save it. I just save it as you can save it as an image. If you saved it as any one of those, I'd import it, but you could save it as an image to your computer. And then you can view it as such. If I bring it over, then you can view it as an image that you created. All right. Questions, comments, concerns about homework 3? If not, feel free to take a 10-minute break, and we will come back at let's come back at 8:10. It'll be a 9-minute break, and then we'll cover homework 2, and then I can answer any questions that you have, or even get started on homework. Hope you get started on homework 3. Sounds good? All right. I see some sidebar conversation. I'll help out with that during break. We'll come back at 8:15. We'll call it good then. See everyone in a few, and I'll answer some. Also, I'll answer some questions here during break too. So see you in a few. Hey, just gonna say I saw the sidebar. I'm happy that the community's helping each other out, answer questions. See if I have any questions here on Slack. It doesn't look like it. So far, so good. I feel this is like between this one and the joins are the two hardest ones for me to teach, because they're the two most conceptual classes as far as like bringing data together. And then this is like really conceptual, is like how you design databases using these models or analytical models. The other ones are hands-on, so they have like straightforward examples, whereas this one is really like explaining how you create these diagrams to design these different types of systems. So if I can clarify anything, or class can help each other out, that's awesome. I'm actually going to end this lecture while we're on break instead of recording. Well, maybe I should record the homework too for the people who aren't here. Go ahead. Homework 2. Give everyone a link here to the solutions. The link in Slack. Take a couple-minute break myself. Be right back. All right, everyone, I'm back. I think I got the dog settled in for the final hour. That was pretty good. So, Douglas, you're asking a question. You think you could land entry-level data analyst jobs with the classes? Yeah, I think that you could. A lot of data analyst jobs are about knowing SQL or being able to work with SQL, being able to take that information and create reports and dashboards out of it that are like representative of the systems and the business rules and the questions that the organization wants to answer. I try my best to have a portfolio of like a project or data that you've done. What you could do is you could publish something on Tableau Public. One second. I can get my mouse cursor out of there. Let's go. Hold on one second. I was going to take you to Tableau Public, trying to get there. There we go. All right, so Tableau Public. I can spell that right. I've actually done this for my own portfolio of dashboards that I built. I actually try to take you to that. I've been logged into it for a while actually, but you may have gone through this in your Tableau class, but there are all sorts of visualizations that people do or create. But this is like totally open to taking some data off the internet and then doing a visualization out of it and then describing like how you did it or why you did it and how you interpreted the information and things like that, and then creating a little portfolio and then your skills with it. Let's see if I still have my examples up here. That's not the right one. Be under my personal email. Where I used to have a portfolio here. Maybe not anymore. But yeah, you can learn data skills, career growth, showcase your work, so forth. I don't know where I'd have to go back and look for my first one, but the more of these that you can put together in projects and talk to, like how you put this data together, the better. I designed the final for this class also, like questions that you would be asked about SQL in a job interview. So based on on the notes, but with the idea that hopefully you'd become like a data analyst, or you'd be interviewing for data analyst positions. But like I was saying before, one of the best ways you probably to get a job as a data analyst is go somewhere and then offer to do the reports and stuff like that, work with data, know the system and work the data. That one's probably a little bit like more of a longer path, or you could potentially take an internship or something like that. That for a data analyst job. Kind of sort of it's not very highly paid, but it's kind of like you get a chance to prove your skills. Probably the most comfortable one, I think. Your most comfortable way of getting in is if you work somewhere and then you offer to do their reports. But if not, I'd try to build a portfolio. Even do a local installation of MySQL database and then import some data and then work with it and create that and put that in Google and talk about how you did that. Showing your potential employer like that you have the skills, or not just that you have like SQL skills or Tableau, but you are able to like take the data and practically do something with it. Just thinking back to my first job, and that's like 2007, so it was a while ago, but I just had like a basic test of a couple skills and they just gave me the job. I might got lucky. I was out of grad school. I feel like I got lucky. It's like a 10-minute interview. Hardly any interviews ever go like that. But I was young and offered to work for cheap, prove myself. Needed a job. Also go look at job resumes, or go look at some jobs and the job descriptions. That's what I was looking for. See where any gaps you feel like you might have and go fill them and then interview for the job. And see if we can. I'll just bring up one right now. Let's bring up some LinkedIn ones. Yeah, but the intent of the final that I create is like questions you might be able to ask. In job interviews, I've had people ask me to write code on how you would do something. Like they might give you like 2 tables or like a few tables, like that ERD diagram, and they'd say, how would you put together this query? And then you would write some code for it. Let's see if I go to data analyst and jobs. Just look in Omaha. Lots of data analyst jobs in Omaha. Maybe not a senior data analyst. Business intelligence analyst would be along the same lines. Some of these are more senior positions. Deloitte. Let's just go with this one at Deloitte. Oh, they're asking a lot in this one. So some of these data analyst jobs, they asking for you to do like work with data, and then even more, like they're talking about like quantitative risk analysis and AI models. Probably not for that price they want to pay. Develop new analysis. To be fair, as a data analyst, you are partially an analyst too. So, like interpreting the data and understanding systems and stuff like that. Let's see, business intelligence analyst. Sometimes the hard thing is just like these job descriptions vary widely. Let's do a business intelligence analyst. Best bank to work for, Access Bank. BI analyst combines mathematical, statistical, analytical, and data mining expertise. I'm asking for a lot on that one too. Analytical approaches, coordinate data from third-party vendors. So yeah. For data infrastructure, I was looking for this one for USO. And they ask a lot. These jobs are asking a lot out of this. Let's do internship or entry level. They're asking you to be like a full business analyst and making recommendations plus doing all this stuff with the data. Let's see. This one might be a good one. I know National Indemnity has a pretty big data team. Data collection. Here's a good job description, I think. So insurance data analysts will be responsible for preparing, analyzing, and communicating working papers and statistical and management information related to insurance and reinsurance operations. Data collection, data transfers, data manipulation, analysis, accounting, activity, financial, and reporting. So they compile data, financial data, look for helping with processing payment requests. So it also helps if you have if you have a background that they're looking for in these jobs. If you have an accounting background, or you have some type of background in like the area that they're looking for, but like someone who has strong SQL skills, detail oriented, so forth. I don't know if I'm hoping I'm to help with someone who's entry level and making the change. I know there are volunteer positions. If you volunteered somewhere and you were able to get experience there too, that's kind of hard though. Data analyst. So this is typical of a data analyst, like doing research, you're diving deeper to help them answer questions. So you're ensuring the intake, delivery, and quality of data, performing database queries, recommend like improvements, validating data. Strong business knowledge, business intelligence knowledge. And there's also a thing called report analyst. I guess it doesn't have any. But I just keep looking at any gaps that you have and continuing to apply, building your portfolio. There's always contemporary analysis too. I sometimes work with Nate Watson on projects. Could always, he's actually had people work here out of Data Science Academy on projects that they have. So sometimes that's just working with data in the first place, extracting it, cleaning it up, importing it into a database, getting it ready for analysis, and doing some light analysis on it. But all those things are what I'd recommend for if you're going into data for the first time, is building up that portfolio and looking at the jobs and try to match skills to anything that you've done in the past, or trying to match skills to your current skills, SQL and Tableau, looking for any gaps and any experience that you bring in the past to help you as a data analyst is useful too. Yeah, that's a long description. I didn't quite find one for you, but if you were interested, I could take a deeper peek for the class and recommend some. or asking Nate if he has any projects. All right, I'm gonna go ahead and go through homework 2. I know that there were some. Yeah, Doug, thank you. I didn't give you a great answer there, but once in a while you may find that you could go somewhere and go to a big company, and then somebody told me once that like some of the best opportunities are there because like a place like First National, you could go there and they're like 15,000 employees, so they constantly have job openings, and you could always apply for anything related to data, and they like always take somebody almost always take someone internally, especially in something like banking or insurance. And there are always data jobs that are being opened by some manager or somebody in operations. If you found that you were having a hard time getting a data analyst job directly, I've actually found a hard time for myself getting data science jobs because just the skills that they're looking for or the questions that they ask or whatever. Even though I have the background for it, but it's a field that's a little harder to get into, I'd say. But you put in the other of those things and keep trying, and or maybe apply somewhere where you have a big company, you're pretty sure is going to have some data openings. Learn a little bit about the business, and like show off some of the skills that you're building on the side. First National Bank is a place I recommend working. Having worked there myself, I learned a lot while I was there. All right, gonna jump into homework 2. Let's bring that up on my second screen. So one thing I did before class, I know everybody's getting hung up on the data imports. So what I did is gave everybody access to the consoles database, read access. So if nothing else, you could use the data that I'm going off of here in the tables. I've imported all those tables. Shortly, I'll also import these views into the consoles table for homework 3. But that way you're able to successfully get through the rest of the homework, like dropping the table and creating these tables the way you need to, especially the imports seem to be the biggest challenge. But what I tried to do, I gave everybody the link in Slack for the homework. So what I tried to do is really like highlight what this looked like at each step, like creating the table, inserting those values, deleting things out, sports games, inserting the record, and so forth. So the first part was given to you. So what happens if you run this successfully would be your own schema. So you create the console games rank table defined as such. I know, Chris, you're having a problem with, it seemed like the rank keyword. Hopefully what I said with the tick marks helped you out, since that's like a reserve word. I found if I put tick marks around all of these, that worked with the column names. Inserting these values, after you did that, you should get results. If you selected the table, had results like this. Then you can start answering the questions once you have that table. So not interested in producing sports games, remove those observations from the console games table. So this is where you can use the delete from keywords, and then you specify the schema and table name. And remember, you always use where to select the rows in the table. So you're using a where statement to tell it what records to delete out of the table. So you see, when you delete it, you go from 10 records to 9 records. You no longer have ID number 8, which is like this MLB 2019 baseball game. Then 3, inserting this title, this Barbie adventure game title into the table, that same table. We're doing this by values instead of doing it by a query. That's where you put those in brackets, and then you define the values for those columns that you're inserting into. And then you get a new Barbie adventure game. All right. So just stop me if you have questions along the way. Feel free to ask. This is what's showing you what this should look like if you successfully import all of these. These are the table names. These are the column names that I got in each table. I put them in the consoles table that everybody has access to. But this would be under your schema, potentially, with all of these table names and those columns for each one. So this may also help if you use this in the future to know what's in each table and answer each one of the questions. Doug, I'd have to take a look at dbeaver, but that's pretty common. Like even here, the database imports were kind of slow, or some people would have like some type of column issue. That could be like as simple as somebody importing it on a Mac versus a PC, and it like reading characters in the file differently. So didn't want that to become a barrier. So, and for anybody who is having a hard time, whether it's dbeaver through SQL Workbench, that's why I decided to give access to that schema and let everyone move forward. Really, I just wanted to see just have everybody go through the import process and see how it worked. And as you can see, it's sometimes painful process to import data into the database for whatever reason. The best ways I found have been programmatically by like writing SQL code or a script. Python code, like a Python script. But yeah, there are a number of ways that import utility or going to transform it at that other side is you try a bunch of different ways to try to get it in there. Or sometimes you have to clean up the file or it doesn't quite work as you expect. So I decided to just let everybody go ahead and have access to it. Not the purpose to torture you in this class. Not intentionally, anyway. All right. All right, so homework 4 is based on the assumption that you were able to complete all of this at homework 3. Once you had the console schema, you could start to answer these questions using joins, unions, and subqueries. So class 4 for number 1, what are the total sales for console games by North America since 2000? So a couple of people said it wasn't necessary to do this in a union all query, which I agree. So you could do this as a genre in action and role-playing games. Just for the sake of this exercise, what I was doing is a union all. And what you could do is separate those two, and then it just becomes the same results that you append to each other. And remember, union all is purely appending both results. So your results would be all the ones for action, all the ones for role playing. Right. So during that time period, the second question is, during that time period, how does role playing games sale compare with other genres? So I took genre and did the sum of North America, Europe, Japan, and other sales as total sales. Scratching from the console games for greater than year 2000, in order by total sales. Let's see, I believe that these are in millions. So then I ordered them. You got this. You can answer the question. So genre action was the highest selling game genre since 2000. So I designed these questions like management would start to answer these questions after you imported all this data. So third one is, what is the most popular console for role-playing games for consoles with first retail availability since 2000? So some of these were, older than 2000. And so we did console games. We joined that with console dates. This is the first one we did joins on. And then first retail ability greater than 2001, where the year of the console game is greater than 2000 and genre is role playing. I'm gonna have to double check this query because I see a couple of first retail availability is 1989, but that's the idea of this query. I'll double check that one for results, and I still have to grade everyone's. So I'll let you know on that one. So number 4, obtaining the average rank of games created in 2014 by genre. How does this order compare with the current video games ranking in the console games table? So we did console games, did genre, average rank, year 2014. We saw the average rank, game rank. Fighting was one of the most popular ones. And yeah, going down, just trying to see what the best answer was. I think I forgot to include the other part. What does it look like in the console games sales table? Let's go ahead and look at that. See how that compares with this table. So this looks like that's the top. Oh, that was the table that we had in the top 10. This we had a couple actions here in the top 10. Few actions. They had fighting here. She had a fighting game as number 1 was Mortal Kombat. Let's see, what else do we have? No racing games. We have a shooter game, $8.99. I'd say that we could see some of those. You could see some of those here in the top 10. It's kind of mixed, but I'm sure I would go with the sum over a whole bunch of console games to see which ones are the most popular in 2014 as opposed to looking at the top 10. Almost always when you can aggregate data, you can see the higher level trend that way. And then does this lead you to additional questions to research or gather data? I left that up to the student based on that. I know with one of the submissions here, I think it's from Rosendo, he had a pretty good idea of what to research next or what questions you'd ask. So this is all about like asking a question about what game they should produce and why or why not they should produce a Barbie adventure game, or what genre it should be. So using this data, you could dive deeper and say, oh, well, what type of, should it be maybe a Barbie fighting game? That would be kind of interesting. Something like that, dig deeper into the top ranking games. Right, I think that's the end of the answers, solutions for homework 2. If anybody still wants to work through it, like, feel free to work through it and hand it in. Does anybody have questions? I still haven't graded the homework that's been handed in, so I still owe that to a couple people. But most importantly, I'm just looking for people to just work through this, especially now that the consoles is out there, and run the queries and try to produce the results and say, I've gone through it, and then that last question, like, what else would I research? Any questions from anybody? Anything anybody would like help with? I'm here till 9:30, so happy to help. There's a lot in this class too, so if there's anything anybody would like to cover in depth, let me know. Here to make sure everybody, do my best to make sure everybody has SQL skills and is able to take them and apply them to whatever career opportunity they have next. Try to give some experience along with it. Try to give my own personal experience. Hopefully it helps. That I've been through, and it'll be come up on 17 years here at the beginning of May. Went by fast. But started in Excel spreadsheets and SQL queries, putting data in there. And then business intelligence has improved a lot since then. So you still use databases, but you use a number of better tools, like using SQL with Tableau or other report generating tools, or even the stuff we saw today, like developing analytical models. There's software called Snowflake that helps you do that. That helps you manage all of that. It's supposed to be like your new age data warehouse. We'll cover more of that on Monday. Learning Python was a big one. Being able to automate data pulls from systems. Oh, what else? You can also do SQL you can write SQL code within Python. I think that's kind of that can help supplement some of the work you do. Your next class is data engineering, and you do some Python in there. It can help you automate some things. But as a data analyst, you'll always run into transactional databases that you have to pull data from, and you have to write queries for them. SQL, I'd say SQL is like it becomes another tool in your toolkit. I think writing Python, if you can write some Python code, that'd probably help you get a data analyst job too. You can pull data and script data, do some of those things, automate it. Import data using Python and Pandas library. Let's see if there are any jobs here. Let's just type in Python. Omaha, Nebraska. Union Pacific has a year-round intern. Internship. Maybe that's not what we're looking for. Data engineering intern. Looking for a highly motivated, talented intern to help us build state-of-the-art tool using generative AI. Well, there is an opportunity into doing data engineering for data science and creating data pipelines. Let's do a different website. I don't like the results that are coming up here. Create a link instead. Bet these results will be better. Data quality analyst and UNMC. Data quality analyst will lead data modeling like we talked about today, analysis and reporting effort, work with stakeholders to gather, organize, and utilize relevant data of the Buffett Cancer Center activities. So one of the big things is that you're doing as a data analyst is also helping gather data. Gather and organize data, that can't be underestimated. Creating optimal processes for data intake, integration, analysis, and visualization. I have to say though, for my first job, maybe I got lucky, but the data warehouse already existed for me. All I had to do was learn the business and write SQL queries and know how to use Excel. They ask lots asked of data people nowadays. Senior systems analyst. Let's see if we can go. I'm working with SAP. Maintaining the integrity. Business intelligence intern. Business intelligence intern is responsible for analyzing and reviewing data that is collected in our current and future products and services. This one might be pretty good. You work with the data science team, which is good. It's an internship at Sandhills. Take this data and apply it to the markets our products are in to better serve our customers. Review calculations for quality assurance. Working with managers and software developers, which you do a lot as a data analyst or business intelligence analyst. Experience with Excel is preferred. Skills in SQL, Tableau, Power BI, and Python are helpful, but not required. That one's probably a good entry-level one. I think just part of it is just the getting that initial experience is the hardest part. Like in data or just in tech in general, like development or consider data. They consider this data people as technical. They kind of consider it IT. Just trying to get your experience somewhere. And that'd mean like going to a big company and then learning a little bit in what department you ever have and then jumping to the opportunity to do data reporting. That might be a really good way to go about it. And then you say, here's the work that I've done. It's night class. I've worked here at First National Bank for a while or wherever it might be. I want to work on some data. Or going through Nate. Right. It is 9 o'clock. I just kind of talked for a while, but I don't want to point. Since he asked a question, Doug, point people in the right direction. Just continue to stay at it and don't give up. It might take a while. Yeah, you're welcome. I had a challenging time getting data science positions, so I just started doing my own business intelligence consulting, working with Nate and some other people, teaching classes. It's hard. I can't get into it's hard to get into AI. I don't even know how to do it, and I even have some of the computer science, and I have the computer science and statistics background for it. Guess one of the projects will come around someday, or I'll just do it myself. Stay at it. Don't be discouraged. Build a portfolio. Look for the right opportunities. Or try to make them yourself. Do you know, recently worked with Ortho, Nebraska. And most of their team, they were like nurses or they did some type of clinical work before they became data analysts. So they were like a not an OR nurse, but just a specialty nurse in one of the specialties. Or they were like an accountant, or they did accounts receivable for a while. So getting payments and collections and applying that and stuff like that. They learn that domain super well. Then they become data analysts for the company. They moved into that role. or call center where somebody knew like all the metrics and call stats and everything and volunteered to do reporting. And guys always have me as a reference, so happy to give it to you as your teacher. That's what I try to set out to do. Make sure, help you out, or have the skills to be able to take those to wherever you go. Like I was saying earlier, be able to work with data. And I think with this class that you'd be able to work with relational databases pretty well. At least get you there and know what you need to do. Continue to build on it, build on the skills. That Creighton has some jobs too. Get into Creighton University. And this one's building and maintaining the data and reporting analysis infrastructure. Be a lot for entry level. Systems data analyst. Let's see previous qualifications. It's asking for a lot. Yeah, an internship or volunteer opportunity somewhere, maybe just going that way, a first step. But I would recommend, if you could, going somewhere and then trying to move into one of those positions. There's always a need. Somebody always needs data, especially at a big company, and more data people. See, act as a technical lead for highly complex projects. Yeah, it's asking a lot too. Yeah, a senior position. I think it couldn't hurt if he showed how you solved the problem with data too. If you did that somehow, answered a question or solved a problem. not quite, can't think off the top of my head how I would just do that from a portfolio. Maybe there's some. One of the hardest things is like you call somebody a data analyst, but there's also so many variations. Job postings, what they ask for. Coursera. Data. Tasks a data analyst identify, clean, collect, clean, analyze, and interpret. Say, what is your most successful, challenging data projects? It's the largest data set. I've been asked some of these questions. Data analysis process. Is there a process for cleaning data? How do you handle that? How do you explain technical concepts to a non-technical audience? So some of it's soft skills too. Look at data analyst. I'd agree with these. Maybe somebody just recommends how they did it. I could recommend Douglas. There is a Microsoft certification out there for Microsoft data analyst, and certifications are huge in IT. That could be potentially worth looking into. Let's see this one. Okay, you'll play a crucial role in shaping business solutions by researching, analyzing data, and supporting technology implementation. $40 hours a week. Okay. Requirements gathering and analysis. It includes understanding various business processes, compliance, and workflows, testing and quality assurance, research and cost benefit analysis, vendor management. So this one, yeah, communications and training. It's still asking quite a bit for an entry level. Business acumen, problem solving skills, adaptability, preferred industry knowledge. So these are some values. Say if they're willing to be a good opportunity, if they're willing to grow someone in that position. Could be worthwhile. I was going to say, some Microsoft data analyst certification. Especially like Power BI. It's probably a good description of data analyst. Profile cleaning and transforming data, scalable data models. Getting started, prepare data, model data. Doing this with Power BI it'd be good because you can create these data models in Power BI also. Nate might have me teach a Power BI class. Probably look for that, but you can do a certification course as Microsoft or Power BI data analyst. Relational and non-relational data sources. And then you could say, hey, I can do all this stuff with Power BI. You guys need a Power BI data analyst. I'm your dude. There are tons of places to look for people who can do Power BI. That might get you in the door itself. Defining a model in Power BI, cleaning it. Yeah, you can do all this cleaning stuff. I got to mention it, but you can do a workflow in Power BI and do like all the cleaning and transformation in there too. I'd recommend that to you, Doug, and learn Power BI to go with it. And say I can do SQL, I can pull this data into Power BI and do all this other stuff. Create dashboards and reports. You could get a job alone. Oh, I did think of that. Being Power BI analyst. But there are a bunch of these jobs. Or I think there would be. I feel like I've seen one of these jobs. Let's see. Let's go back to LinkedIn. Power BI reporting analyst. Those are people I want to see jobs. See even senior Power BI developer. Let's do Omaha. It's asking for Azure. Power BI developers. Some remote jobs. I know just from the clients I've worked with that there are opportunities with Power BI, where if you learn Power BI and you become an expert in it and you can import data and create your own data models and be able to report off of it. Getting certification is not a bad idea. Then you're certified and then you could show it and then do a project or two in it. More and more companies are moving to Power BI also. Yeah, all sorts of. little bit of everything. Or take a cheap course on Udemy. I just took one to learn WordPress. No, Power BI. Yeah, so you type in data analyst. Data analyst boot camp. It's for Python mostly. Excel, SQL, Tableau. P300 certification, Microsoft Power BI analyst. I have a class for $14. Then for certified, someone will hire you. Trying to be as helpful as I can just from my experience. These be kind of challenging to get into. But if you can get in, you're set. You're a made man. We all build the skill inside a business, and somebody's always going to need you. Have any questions, Doug, just let me know. Douglas, let me know, or send me a message, or I think my email's on the syllabus. Always try to answer a question for you or give you a reference. Sweet, good luck. And like I said, reach out, let me know. I think this class was a good start. Yep. See you Monday. Thanks, bye. Right. So go ahead and end this class. So this ends a class on structuring and modeling data, class 6 of SQL 101, spring of 2024 for Omaha Data Science Academy. I'm Jeremy Bergman. Next week, we will talk about managing and storing data within the organization. So from start to finish, from transactional systems to dashboard, we'll look at that entire workflow and everything related to data in an organization and what a data analyst can expect. So until Monday, see you next time.